Okay, I think we have a quorum. Thank you everyone for joining. Again, my name is Pierre Lapointe. I'm the Customer Care Manager for Nextbee. I'm here with Philippe Ambredan, Nextbee's CTO. We're excited today to have you on the phone and to be able to show you our open source project, ScanCode Tookit. We'll have a few slides for you to explain the project and what we're trying to achieve with ScanCode Toolkit, and we'll jump into a demo right after, so you can see concretely what you can do today with this open source project. It's available on GitHub today, and you are free to download it and start using it. This session is recorded, so we can publish it afterwards on our website. And if you have any question, feel free to ask them in the GoToMeeting panel. Philippe will also make some pause during the demo to ask for feedback. So don't be shy and don't hesitate to ask anything you'd like to know. That's about it. Philippe, take it away.
Yes, thank you, and good morning, everyone. So, agenda for today: introduction to ScanCode Tookit, a demonstration, and we can dive into the details if you're more interested to understand how it works. And let's go from there. So, I'm assuming that most of you are familiar with open source licensing, otherwise you probably wouldn't be there today. When you think about colloquial expressions we use for software licensing, we often say software is under license or under copyright, which is an interesting term. And if you think about it, what we're trying to do is to uncover the license and copyright to be able to access the software that's under it. But more practically, there's a lot of benefits to have an open source scanner, and a few reasons why you would want to have such a tool. First, you want to be able, as a developer, to get access in a normalized and structured way to comprehensive license information. And I wish they were always clear and simple. Of all the open source projects, the largest one that's probably the cleanest in this respect is the Debian Linux distribution, where they make a lot of effort to provide detailed information about the original license of the components and package they redistribute and assemble. But very often, this information is everything but directly accessible. It may be buried at two levels. First, inside files, which may be deep down inside the component, or at another level, which is inside dependent components or dependent packages. These dependent packages may not exist in the source code tree, and may only be fetched at the time you effectively build the software from remote package repository like NuGet, Maven, NPM, PyPy, RubyGems, and the likes. So things are not really self-evident and straightforward. And what we're trying to do with ScanCode is provide a tool that can help developers easy access to this information. And once you have this data, you can act on it. And act on it, so there's multiple purposes. It could be to ensure that the license is something that you are okay with in terms of your own policy. So if I am a GPL developer in a GPL project, I probably don't want to use commercial proprietary software in my code. And conversely, in some case, I may not always use certain license in a commercial package and so on. So it's a matter of policy, but you need to have the data first. You want also, once you know that, to be able to comply with this license, and if you don't know what they are, it's hard to actually comply there. And compliance is fairly straightforward in most cases. It's producing some attribution notice and redistributing the source for copy left if needed. The point here is that by capturing the data in a structured and standard way, and uncovering all the data that's effectively buried into either the code itself or its dependencies, you can have a clean and clear way to communicate with other parties in your team or company on the legal and business side. So that's really to remove the guesswork. Now, what does ScanCode do today? It scans source and binary code. And inside that, it will find licenses, whether there are license mentions, notices, or whole license text. It extracts copyright notices, and that's actually not an easy feat, weirdly enough. There's so many ways people can write copyright statements. It also collects package level information. Most of these package manager formats have metadata, in some case sketchy, but in some case conclusive, and they provide high level information about what the package is, what its license is. And it collects also other clues which may be interesting to determine affirmatively the provenance of a piece of code, such as emails, URLs, authors, and other things which are interesting in the code. So, in terms of output, today what we have is three things. First, a JSON file, which is a structured output that could be reused by other tools to consume the data collected by ScanCode. A dynamic HTML application, which is mostly what we'll be looking at in a minute on the demonstration, to browse the results and search, slice, and visualize the summaries of what's been scanned, and a static HTML table that you can also open in a spreadsheet in Excel or similar tools. All right, any question at this time? Feel free to post a question if you have any. Otherwise, I'll jump into the demonstration. Okay. So I'll jump right away in visualizing some results of a scan. Let me make that a tad bigger. So what you see here is the results of scanning and opening in my browser the scan of a fairly large JavaScript library called SenchaTouch. It's available under GPL or commercial license. And what you see on the left is the tree of files that were found in the scan. On the right, you have a certain number of panes where you can see and search the license, package, and license summary. So let's look at the license summary first. And what we see here is a small bar chart, and we see that there's about 6,064 files that don't have any license information whatsoever, which is, well, it's unfortunate, but that's the way this project works. And while it's overall GPL, we see also there's GPL 3.0. So what would be interesting here would be to actually search for where we have these GPL mentions. And we see that they are here in the license file proper. You see exactly, by the way, where this information was detected, the license, the start and end line, so it's pretty informative and accurate. when you have a license that's detected, you have a few more information. There's more information that are available in the JSON itself. But here, you have a high-level category and a link to the public ScanCode demonstration environment, so you have access there to the whole license text, some more information about the license requirements, which are available in the public ScanCode Deja code demonstration. So let's go back to ScanCode proper. So now, let's look at how things work at the command line level. So ScanCode is a command line tool. Here I'm doing the demonstration on my laptop. I run Linux, but it works equally well and exactly the same on Windows or Mac. And we're pretty careful to ensure that it's both tested and used and validated on all these different platforms. So there's a command line tool called ScanCode with some help about all the things that can be done with it, And you have a certain number of scan options. So you can scan all these different things here. Copyright license, package, and what we call info, which are general file information, such as checksum or the file type. Then you can select the format. The default format is JSON, but you can select HTML, HTML app, or JSON. And there's some more information about examples of what the kind of commands you run. But if we run a sample scan, so let me check where I am here. And I'm going to run a copyright and information scan on the samples directory here. I'm going to ask for a format which is the HTML app. And I'm just going to save that to a file called sam.html. So what you see then is just a small progress bar, which shows you how many files were processed, and it was pretty sudden, but the file names being processed was also being displayed. And if I open this file in my web browser, this is the result I get. So here, there's no license summary. I didn't scan for license, I just looked for copyright and file information, but I can see the copyright here. And I can browse on the left to focus the view on the right, or I can also search for specific things. It could be a license, it could be a copyright, or part of the file path. And here I have also file information. So in this case, it's ADS file, which is written in ADA, which is a plain text file, which has a certain number of checksums and was written in 2004. You have size information and so on. Let's go and look again at a few more scans. So we looked at this touch scan here. I have another scan which I've prepared here, which is a scan of another tool called BusyBox. Which is a bit more interesting because there's a bit more variety here. And so the first thing you see on the license summary, and that's interesting, is we report places where there were no license found. Well, that's void in some ways, but it's important to understand this information because no license is an interesting fact in itself. Then we have code that's under GPL, and it is sorted by number of occurrences that were detected. But you see that while BusyBox is overall GPL2 licensed, There's a lot of other licenses there which may be considered. You have BSD original, artistic, be aware, and many more things that were also found. Interestingly enough, there's some code that's under GPL3, which you wouldn't expect in a package that's GPL2. And you see that in this file, ThatMode, here, I'm going to copy the path. There's at line 71 a reference to GPL3. So let's look at what it is. So if I go to line 71, that's actually a bug. My bad. It's a bug that was detected yesterday. So it's a live demonstration. Here, the way license detection works is that it uses rules. And it did mistake this string here with GPL and 3 as being a GPL3 license. It's actually interesting because this piece of code here, ThatMode, is effectively GPL2 license. What it does, it's a utility on Linux to verify and load kernel modules. And among other things, what it does is to check the license of the symbols of the kernel modules. And it checks whether it's GPL or not. Because when a kernel module is not GPL, then it has access to fewer things. So the way ScanCode works is that we can very easily ensure that we can fix this bug. And the way this would be fixed would be by creating a new small piece of data in ScanCode that's called a rule, which would contain this string here. And we would say, when you find this, really don't detect a GPL or a GPL3. This is not a license. Okay, so let's go back to our results here. You can see how we can basically navigate left and right. Again, focus on the left, access file information if they were collected, package information if there are any. So do we have any here? We just have one, which is a plain archive, which has been detected as a package that we could look at furthermore. And again, our license summary. So that's the essence of the things you can do with ScanCode. And a few other things we can do is when you look at code, one of the things you want to do is ensure that the code is eventually fully extracted. So there's a command called extract code, which will fully and recursively extract all the files in the archives you will feed it to. It's slightly different from tools like tar or unzip, because it recognizes all the archives format on the one end, and it also extracts archives in archives in archives recursively. And it ensures that the files that are extracted look the same and are extracted correctly regardless of your operating system. So some file systems, like on Windows, are case insensitive. And if you were to extract naively a Linux archive for the Linux kernel on Windows, you have files which have the same name in the file case. And when you extract that on Windows, then some files will be overwritten. So extract code takes care of effectively ensuring that you can extract things correctly on all operating systems. So let's do that on the samples directory. It was pretty quick. the output, if we look at what was effectively extracted, is, if we look at samples here, we had a sample archive. So we did extract side by side, in this case, zlib. And again, if we now scan this sample directory again, maybe just the, well, let's scan it all. LCIP, samples. I'm going to ask again for an HTML app. And I'm going to save that in samples2.html. So while it's doing the scan, a few other things we want to look at. So let me open this sample here. So this was our initial sample here, and there was no file detected here because we had not extracted fully the archive first. Now, if I open this samples2.html file, and I extract and expand, I can see now more things were effectively being detected. In this case, it's all under the zlib license. I can see also that we also have, in this case, a plain table that was recognized as an archive as a package. If it had been a Java archive, it would have been detected as a Java archive, or a NuGet package, a gem would have been recognized in the same way. So that's the gist of the features of ScanCode. As you can see, you can focus on the left and view a license summary just for this directory. You can focus the search. So if I'm looking at everything that would be GPL here, then I can look at my summary. Actually, no, the summary is not filtered in this case. But I have even some weird license like this ADA exception, which you can then look up on ScanCode.
Philippe, we have a question in the chat.
Sure.
Asking if this tool run only from the command line. Can you comment on this?
Yes. So the current version runs only from the command line. We have in the pipe, I don't know if I have there, we have, so I don't have the things prepared for that, but we have a server that's in beta, and that's going to be released publicly soon, which is going to be available as open source too, and on ScanCode.io as a demonstration environment. What the server does is the ability to enter an arbitrary URL on the home page. So let me see if I can find a way to show that to you very briefly. I just need a second. So what the server does, it can access an arbitrary URL, which could be an archive or the URL to a GitHub repository that runs the scan, and you can optionally put your email if you want to get the results by email. And the other thing it does is that it also exposes a webhook. So if you have a repository on GitHub, for instance, and you would want to have a scan done on each commit, Every time there's a commit, this webhook can be called by doing the proper configuration on the GitHub side, and you would be able then to have a scan that's launched on each commit. So that's the way it works. Does it answer the question?
Yeah, I think so. Yeah.
Yeah. So just one sec. I'm trying to see if I can find the fine URL I had to show you at least what the ScanCode Tookit, ScanCode server will look like. There we go. Let me share my screen again. I was temporarily zapping elsewhere. So that's what it looks like. Here you can put a download URL and then view scan results. So let's look at this example. The look and feel is slightly different, and it's going to be unified with ScanCode. What you see here is a few examples of different visuals using a tree map for license and copyright as opposed to a bar chart. But you see here we scanned a repository, and the way this was, the scan was requested was just by pasting the URL on the home page and pressing enter. So that's going to be the primary function here on the ScanCode server. Beyond that, as a second step, we'll be also adding features such that you can organize your scanning projects. And eventually private projects, so you can have a scan for this product or this product, which are clearly separated and with restricted access. And so that's the gist of it. And features to help you once you have scans, being able to go to the next step, which is how do you come to a conclusion? I mean, it's one thing to have the raw data about the scans, but the second step is how do you come to a conclusion to the effective license? It's very common, for instance, in the Linux world to have a package which has a dual license, two licenses at the same time. The library will be under an LGPL license. Examples, most of the time, would be in the public domain or some BSD license, and you have command line tools which are under the GPL. So this information will be surfaced by the scan, but then it's a matter of how do you use the code that will determine your obligations. If in a product you're only using the library, and therefore you're not redistributing binaries, and you're not using the command line, then you're really interested about the portion of the code that is under LGPL, which has different obligations and compliance requirements than the part that would be under the GPL. All right, so let's go back to our slide demonstration. Just for the sake of it, even if it's not super interesting per se, this is how things would look if we were to look at a JSON output. So that's the output that's provided as JSON, and you have location and the various information which are detected as you can see them in the HTML information, in the HTML application. The important thing that's to consider here is that it opens the ability to apply more tools, more intelligence on top of the results of the scan, and integrate that in a larger tool chain or larger pipeline of which scan can be part of. it's also something that will be exposed, by the way, as an API in the ScanCode server. Okay, so let's move on to the rest of the presentation. So it's available on GitHub. We provide commercial support if needed. The code is under an Apache licensed. For the data, we use public domain. The license still requires an acknowledgement, which is mostly a warranty disclaimer in the scan output, because we are not lawyers, and the results of ScanCode is not legal advice. We also use several third-party components under multiple licenses, pretty much everything except probably Ashero GPL and Sleepycat. But we use code under GPL, LGPL, MIT-BSD, Apache. The way we use GPL and LGPL, GPL code actually, we use some LGPL libraries, but the way we use GPL license code in general, and actually not in general always, is for a certain number of command line utilities, which are used as is in their own processes. So that should normally not have an impact on the overall license of ScanCode itself. Now we have a roadmap that's available publicly. We can have a quick look at it. So it gives you a bit of an idea of what we're working on. The current work is on reporting additional clues, which are already exposed internally, but not in the scan results. So email authors, but also unknown license. Sounds a bit weird to be able to detect an unknown license, but there's ways to do that. And approximate license detection. Just for the small story for unknown license, the way it works is that if you think about the set of license text and mentions that we use to drive the license detection. So if I show you a bit of this, so you have each of these files is a different license with its metadata. There is about 1,000 of these from the license side, several thousand on the sample mentions and notices side. There's a finite set of words that is used in all these legalese. And these words are very specific to the licensing domain. And we can build statistical model by counting the frequency of how words exist in this data set of the confined world of software licensing, and finding occurrence of these words for license we don't know yet of in ScanCode, but that exist in a text file, are a very strong indication that what this text talks about is about licensing. So that's just to explain you how things work there. Let's go back to the roadmap for a second. We're working on improving the scan UI, and there's other work in progress which will go in the future release after the one we're currently working on. So we talked about the ScanCode server, that's one of them. We also have written specific extractors and analyzers for many different software package formats to extract the metadata and make them visible in complement of the effective scans. So if you think, for instance, about the Windows nuggets, the package contains XML files, which are meta information about the origin and license of these nuggets. And there's, for instance, a tag which describes what the license, what the package name is, You have the same kind of information, of course, in RPMs, NPMs, Ruby gems, and many others. Some of them are pretty sparse in some case, but these are important pieces of evidence. So that's the key things we're working on, and you have a more longer-term view of what will be the next topic that will come after that. So at this stage, I'd like to open the discussion to questions. I have a lot of backup slides that we can dive into, which explains how ScanCode works internally. And if there's a question on this topic, I'll be happy to dive into these ones. And if there's no question, then I will dive into these additional topics. Okay, no question at this stage. Let me move on then. Okay, quick credits to the folks that helped prepare this presentation. So some high-level numbers on ScanCode. We're pretty intense about testing, and we run continuous integration on Linux, Mac, and Windows on each and every commit, and each time there's over 6,000 tests which are being run several times a day. We have collected thousands of licensed text and created them, as well as thousands of licensed samples and mentions. The purpose of them is to be able to say what is a license, what is not a license. We saw an example of a bug a bit earlier on for this misdetection of GPL3. The tool has been in use for several years until it was made available as open source in the last few months for NextB to deliver professional services. And there's been a large number of significant commercial products that were scanned with this tool successfully. In terms of technology, it's primarily written in Python, but we're not religious there. We use JavaScript, of course, on the UI, but also elsewhere. Some bits of Ruby, Java, C, and C++. It's primarily a command line tool, or it can be used as a library too. And as I said, we have a server that's in the works. The point is that even though it's a command line tool, the output is browsable HTML. And once you get past the hurdle of being familiar with how to use a command line, even a non-technical person could possibly use ScanCode and look at the results. We had some requests and some feature suggestions to provide some mini UI wrapper application, and that's something we may consider. But in earnest, at the moment, the focus is more on providing a solid server backend rather than a enhanced desktop application. So now, let's go back a bit and understand what scanning is about. It's about detecting evidence. So evidence actually exists in the code. It's important to understand that whatever is closest to the code may not always be 100% right, but in most cases, that's what lawyers would consider as the most significant. So looking at the code itself and finding evidence in abstraction of anything else is really what scanning is about and what is important. But what you have to understand is that scanning is not matching. What matching is to find similarities between some piece of code and an index of code that would be typically open source code that you would have collected and indexed. So scanning is not matching. Here, we don't do matching. Note that for matching, the notion of similarity, if you ever use one of these tools, most of them are commercial, it's an indication of similarities. Two pieces of code may have been written entirely independently, for instance, using Visual Studio or Eclipse. And there's a lot of boilerplate code that can be generated by these development environments. And therefore, the code will look very much the same, even though it has been developed entirely independently. So that's the difficulty with matching. And there's really also multiple levels of matching. You can look at whole packages, as well as file and snippets. Commercial tools that do matching today are primarily focused on the lower levels. So when you think about the two combined, scanning provides you, in most cases, my experience is anywhere between 80 and 90% of every third-party content that exists in your code base. What it will not catch, of course, is things that have been modified intentionally. So remove notice, remove copyright, and so on. That, by virtue of being removed and hidden evidence, is not detectable by a scan. We don't see that done in practice very often. So but it's still an issue in the sense that it's a threat to the validity of the scan results in general. The problem with matching, on the other hand, is that it doesn't detect certain things. If it's not in the index, it will not be found and detected at all. My experience is that there's anywhere between 10 and 20% of the code base that is not positively detected by the best available matching engines, which are commercial, which are in most cases detected by the scans. So the two are complementary in a way. You need to be able to do some level of scanning and some level of matching. The difficulty also on the matching side is that the state-of-the-art of algorithm produce a lot of false positives and requires intensive review work. You don't have a simple answer like you have with scanning, simple and straightforward, but you may have thousands, if not tens of thousands of possible matches to review. Now, that said about matching, we have developed internally and are using our own matching engine. And we'll at some point of time in 2016 consider making this also open source with a focus on package matching, and that will be part of the ScanCode tool suite. Now, any question at this stage? Otherwise, I'm going to dive into explaining how ScanCode works. No questions? Okay. So how does ScanCode work? First, we start by categorizing files. So we understand what is the file type. Is it source code? Is it documentation? Is it an archive? For now, you've seen that the extraction is a separate tool called extract code. But part of the plan is to make this extraction of archives transparent. So archives are eventually fully extracted for now in a two-step operation. And then we collect the text available in files, whether they are text files or whether they're eventually binary files like a Windows executable, Linux ELF, a Java class file, which is bytecode. Then we scan the text file and return the results as JSON, eventually available also as with an HTML front end. Now, the techniques we use for the scan part, for license, it's essentially similar to DNA analysis or multi-pattern matching. You could think of it as a search engine like Google, but the other way around. When you think about a search engine like Google, there's a very large index, the whole web. But the keywords, the queries you do on this index are small words. It's just a few words. So the query is very small, the index is very big. In contrast, when you think about license, the index is relatively small. I mean, by having a very comprehensive coverage of license text, mentions, samples, and notices, you're talking about 20, 30 megabytes of text. So the index is small. On the other hand, the queries could be multi-gigabytes of code that you're trying to find licenses in. So the problem is, at some level, closer to what you do when you do genomics, where you're trying to align strings, which is not strings of DNA here, but strings of license, between a large body of text on the one end and a smaller body of text at the other end. And so we find both exact and approximate match. The important thing is that we return exactly where it's found. You have the exact position in terms of lines and character offsets. Eventually, that's something that we'll expose also as a feature to extract and collect the actual text that was found in the code base. For instance, to produce attribution notice. For the copyright side, I wish the copyright detection was simple and a simple regular expression would do it. But it's actually much more complex, and we had several iterations on how to properly find and collect accurately copyrights. That's probably the fourth iteration of the approach. And what we use today is techniques borrowed from natural language processing, where we first build a syntax using what's called a part-of-speech tagger to identify elements that constitute a simple copyright statement. And then we have a grammar which consists of all the different forms and permutations, the word copyright, a copyright sign, year range, and a bunch of names may be assembled in various ways. And that's surprisingly efficient, but surprisingly complex for just finding copyright. Complex, we're talking about somewhere in the range of 1,000 lines of code, which for a dynamic language like Python means a lot of code. So it's surprisingly complex for something that's as simple as copyright. Plain regular expression works probably 80% of the time, if not less. Then for email URLs, we use similar techniques or regular expressions. Now let's look a bit at alternatives to ScanCode. There is a lot of excellent open source tools out there. Most and foremost, Fossology, which is the grandfather of it all. It's been out there for probably close to 10 years now. It's a project that was originally sponsored by HP and now part of the Linux Foundation. It's written in C and PHP. The primary approach for license detection, but that's not the only one, is based on a large number of regular expression patterns, which has its challenge in terms of maintenance. But because this is compiled, it has also advantages because it's a tad faster. Ninka is another one using a different approach. It's a Perl script. And the last one that's still worthy of a mention is called OSLC, Open Source License Checker. It's a Java-based tool, but it's no longer maintained. It was something written by students at some point of time and probably left aside after the term was completed. I'm sure you know about the commercial tools in that space. Weirdly enough, not many of them are able to do proper scanning, which is the first thing that's the most important, in my opinion, which is when there's evidence about a license and an origin derived from copyright in a piece of code, you should rely on that before anything else. And so the focus of most commercial tools has been on the matching, as I said, and mostly on the snippet side matching. So I strongly encourage you to look at these other open source tools. On the complementary side, we have other projects about code, which is a tool to document the scan results and conclusion inside the code base. So once you've made the effort of finding where a piece of code was from and came to a conclusion, then you can record that information in a small YAML file inside your code, side by side, and use this information for different things. First, collect inventories. Second, generate attribution, and eventually generate punch lists for source code redistribution for license that require it. And so it's a way to manage this information side by side with the code as a small text file committed. You can think of it as a package management format, like a package.json for Node or a Maven POM that is technology neutral and whose focus is primarily the documentation of origin license and provenance, generally speaking, as opposed to documenting dependencies and how a piece of code should be built. And trace code, which has not been released yet, but will be soon, is a tool to determine how source code is being transformed into compiled code or minified JavaScript code. And it's an important thing because when you think about a typical code base, you may have a lot of code used in development by the programmers, which is test code, tools, compilers, prototype, dead code, which is never part of the code you effectively redistribute in a software product or application. And if you scan this code base, you will find license for all these things, even though they may not be part of the effective piece of code that you are concerned with. And so what trace code does is looking at the binaries as you redistribute it on the one end, looking at the source code on the other end, finding what is the subset of the source code that is effectively used, how source code is combined to binaries, is it statically linked, dynamically linked? What would be bits of code that exist in the binaries that don't exist in source? We talked a bit earlier about package managers. If I develop in Java, I most likely be using Maven or Ivy as a package management environment. All the hundreds of third-party jars that I use in my deployed product don't exist in my version control system. They only exist once I build my binary. So this is code that you need to figure out where it's coming from, and that's what trace code helps you with. And so there's two flavors of it. One is a static analysis, which looks at the binaries and does an analysis of the binary, looks at the source, and compares and match the two. And then a dynamic approach where you effectively run a build under the control of trace code, and it captures every actions done by your build code, whatever the build tool is, and reconstructs a graph of the build. So which are the files which have been read, processed by this process and tool to be written in this other binary file. So it's a different approach, but the results are the same. And that's pretty much it. So that concludes the presentation. We still have a few extra minutes for questions. So at this stage, please chime in with questions if you have some more. Otherwise, you can contact Pierre, me, or anyone in the team, either directly on GitHub, or since you've received an invitation, you probably have the direct contact information. And I look forward to your using ScanCode and eventually contributing with bugs, suggestions, features, and other things.
Thank you, Philippe. And again, this is Pierre. We will be sending you the link to this recording and the slide this week or early next week. If you have any question, you can follow up with me, and or, as Philippe said, anybody at NextB. Thank you so much.